So good morning to all of you. For me, it's afternoon. Good morning to all of you, and welcome to our presentation titled Multi-Criteria Assessment of Spare Parts of Hydraulic Systems. This research will be presented by me. My name is Nuno, and I'm a student in the University of São Paulo in Brazil. And my advisor is Professor Valerio Salomon, also from São Paulo State University of Brazil. So my presentation, it will have 6 items. The first one is quartership, introduction, literature review, critically of spare parts, methodology, results, discussions, acknowledgements, and references. As I just present myself, my name is Nuno Torre. I'm Portuguese, and I'm a marine engineer. I took my diploma in the nautical school in Lisbon in 1999, and my advisor is Valerio Professor Salomon. He's Brazilian. He's got a doctor engineer in the University of São Paulo, Brazil, and also he's got a postdoctorate in the University of Pittsburgh in the United States. So at the moment, I'm working in the huge steel plants in the southeast of Brazil, and that's why I choose this the theme of this paper. Introduction. In the steel industry, the spare parts critically assessment for hydraulic system is a problem with uncertainty. Not only depends with the costs associated. So our motivation of this study is to develop a useful tool for helping maintenance managers with decision-making problems concerning the hydraulic systems spare parts. So in this context, our goal is to present an evaluation framework for managers of spare parts for hydraulic systems in steel industry. There is a wide range of MCDM, multi-criteria decision-making methods, such as MIUT, MIVT, TOPSIS, fuzzy, etc. We choose analytical hierarchy process due to simple methodology and easy understanding. And in this context also, our research question is how to use a multiple criteria approach to develop an evaluation framework of hydraulic spare parts critically assessments in the steel industry. Okay, as I told you before, I'm working with hydraulic systems in the engineering department, and I take care about this problem in my organization. In the literature review, we choose in the database of Scopus articles, articles and reviews, conference papers and reviews, and also open access articles from the last 10 years, since 2013 to 2022. And we select over here in this figure, we have the evaluation of the publication since the last 10 years. And we choose only in the last 10 years to aiming to pick up the most recent articles. And we type the keywords AHP, MCDM, hydraulic systems, and spare parts. Over here in the figure on the left, we have the country distribution, where we have the United States in the first place with 8 items, and in the second place, China and Brazil tied with 6 items. On the picture on the right, we have the research area, where engineering got 41%, so is the most frequent topic for this research. In the second place, we have computer science. On the third place, business management and accounting. So from the 263 articles, we choose only 50 to develop this research. About the critically of spare parts. Critically is one of the most used criteria. The spare parts critically assessment shall be based on the logistics and maintenance requirements. This it was cited by Antons and Rednayak in 2019. Hydraulic systems performance demands a high level of availability, which can be reached by appropriate measures. It was also cited by Pavlov, Polinin, and Kozlov in 2018. And the steel industry is seeking to introduce new management concepts with wiser insights to warranty the quality of their products. So organizations need to choose their partners and establish strategies that optimize their results. So Dashmond and the Sunderman 2018 and Lutus 2019. The methodology. Just a moment. So as I referred before, I'm working in the large plant of Brazil Industrial Group that operates in the steel market. So we have more than 10,000 employees in this organization, and we operate a large-scale equipment such as hot strip mills, cold strip mills, blast furnace, steaming process, among others. And we choose 3 experts for making the interviews, questionnaires, and also making the judgments. And the 3 experts that we choose, they are from the engineering department and also from the maintenance department of the production area that we choose. So the specialist 1 is a production engineer with 44 years of experience. The specialist 2 is a marine engineer with 24 years of experience. And the specialist 3 is a mechanical engineer with 20 years of experience. About the methodology, the analytic hierarchy process, AHP, is a method of multi-criteria decision-making, MCDM, with great efficiency and flexibility. It was cited by Sati and Vargas in 2001. So our research got 6 steps. The first step is to structure the decision problem into a hierarchy, choosing criteria, sub-criteria, and assigning ratings. I want to refer that all the criteria and sub-criteria we pick up from the literature review, and also a group of experts, they decided which one they choose. The second step is the comparison of criteria and sub-criteria by K experts. In the step number 3, we have the aggregated comparison matrices A are obtained by aggregating individual judgments, AIJ, priority vectors W were obtained, and the calculation of consistency ratio should be less than 0.0. Otherwise, the experts need to make again all the judgments, okay? In the steps number 5, we have K experts, they gave values to the critical spare parts according to the proposed ratings. And in the step number 5, the achieved priority values are calculated using the balance weights technique. And finally, in the step number 6, we have the alternative with the highest overall priority. It will be the best alternative. So over here in this figure, we have the hierarchical tree, which consists in the goal, the criteria, the sub-criteria, and the ratings. So in the beginning, the experts, they compare the criteria with the goal. So the criteria, we have the criticality of equipment, we have the logistics, and we have the maintenance. So they made these comparisons between the goal, okay, through the criteria to the goal. After the experts, they compare the sub-criteria with the criteria, and concerning the critical of equipment, we have 3 items. Life cycle, predictability failure, and repairability. Concerning the logistics, we have the price, the lead time, and the suppliers. And concerning the maintenance, we have the maintenance policy, the frequency of use, and the employees' qualification. And finally, we have the ratings. For the ratings, we choose the technique ABC or the VAD, okay? About the results and discussion. So over here in this table, we have the aggregated priority of criteria and sub-criteria. So the criterion overall priority, we have in the first place, the criticality of equipment, with about 50%. And with this criteria, the most overall priority of sub-criteria concerning the criteria of criticality of equipment, we have the predictably failure with 61.89%. Through the logistics, we have the suppliers is the most important sub-criteria with 67.77%. And concerning the maintenance, we have the maintenance policy with about 63.05%. So over here, we can see the most important criteria and the most important sub-criteria considering the hierarchical tree. So over here in this table, we have the spare parts priority. So all the experts, they gave values to the critically spare parts according to the proposed ratings. So considering the technique ABC, we have the C11, C12, C13, C21 and C22, and also C32 and C33. And for the technique VAD, we have the C23 and C31. So the values for each subcriteria were calculated according to the critical spare parts A, B, C, and D, using the weights of the ratings. And finally, the sum of the results was made. The chief priority values were calculated using the balance weight technique, okay? So that this table presents the reached scores of subcriteria, the priority, and the final ranking in the line which with each spare part. So
no, I will be giving 2 minutes like I did Deepa. So you should finish in 2 minutes so that we will
okay, I'm finishing. Perfect. Okay, so over here the ranking we have in the first place the spare parts B, and in the second place spare parts I and C and D. This is my last slide. So ordering the hydraulic spare parts, we have the spare part B in the first place, spare part A, and practically tied, we have the spare part C and D with only a difference of 0.97. So through the framework that we proposed and the sample methodology of AHP, it's easy to identify the most relevant criteria and sub-criteria. So this hierarchical tree is a very useful tool for helping maintenance managers with an assertive decision making. And the fuzzy AHP or other decision methods, such as multi-attributes with utility theory, can be applied to confirm the achieved values. So thanks a lot for your time, and all regards from me and Professor Valerio, which unfortunately he could not stay here. Bye-bye.
Thank you very much. Anybody has any questions? Nuno?
I have some comments. I really, I enjoyed the paper. I come from the petrochemical industry, and certainly safe, reliable, and competitive operations is important to that. I didn't recognize safety or operability in your criteria, so maybe that's in another area. The other consideration to use on spare parts is network reliability analysis, looking at the system versus the reliability of each component and how that ties together. And there's tools out there to look at that. So if a pump is 0.9 reliability and another component is 0.9, that you get 0.81 for the system. And so how does that fit in together? But I really like the AHP in tandem with some of these other things. I think that's you're onto something there, right? How to get expert opinion and how to get some real excellent data into that. So congratulations on that, and thank you.
Thanks a lot, Professor.
I have one suggestion. John, sorry, could I say something?
Yeah.
Maybe I will give you. I have one suggestion. Although you have used AHP, you can still do analysis because each alternative might have different strengths. So based on each alternative, what are the strengths of alternative? If you do this analysis as well, so it will be somewhat AMP approach. And I think I will be quite curious what will be the results. And I would suggest you do some kind of sensitivity analysis, because in decision making, finding it's just one solution is just starting point. From there on, you should do sensitivity analysis, then managers will be much more, and quite probably you are maybe one of the managers, but they will be much more satisfied with your
okay, Professor, I will take that in my notes. Okay.
It was very, very good. It was very good presentation, as Mr. Clark said. I think it was very interesting. Thank you very much.
Okay, thank you very much for your consideration.
John?
Just a quick question, related to what Birsen was saying. It's very interesting. When you came to the conclusion on the priority of the parts, is that priority influenced by the availability? I mean, is that priority suggesting how much to inventory those parts, or the inventory?
Yes, is concerning the inventory, because in the spare parts, like we work in Brazil, and a lot of spare parts, they come from Japan, they come from Germany. So we take care with that, because if hydraulic systems stops, because if we don't have a spare parts, we can stop all the production. So for sure, we will be in trouble.
So I was just going to mention, going to what Birsen was saying, if you use an ANP model, then you could influence the alternatives by the availability of the parts. So some parts, while they may have a high priority, they also have very high availability, which means you don't need to inventory them. So anyway, that's a further discussion. But thank you very much. It was
okay. Thanks a lot, Professor.